In this video, we're going to work with imaginary and complex numbers. An imaginary number is defined as I equals the square root of -1, or I squared equals -1. The set of imaginary numbers is made up of numbers of the form bi, where b is a real number and b is not equal to 0. Suppose you were asked to simplify the square root of -16. This could be rewritten by removing the negative sign and writing an I out in front of the radical, I square root of 16. And since 16 is a perfect square, we could rewrite this as 4i. Now suppose you were asked to simplify the square root of -13. Again, that negative sign can be rewritten in front of the radical as I, square root of 13. Any number that can be rewritten in the form a plus bi, where a is a real number and b is a real number, is a complex number. We can perform operations on complex numbers. For example, suppose you were asked to subtract 6 minus 2i minus 3 minus 5i. We would start by rewriting the problem without parentheses, distributing negatives where necessary. So we would have 6 minus 2i minus 3 plus 5i. Then we would combine like terms, treating our imaginary numbers as like terms. 6 minus 3 equals 3. Negative 2i plus 5i equals plus 3i. And this answer is in the a plus bi format. Now suppose you were asked to multiply 3i times 4 minus 5i. We would use the distributive property. 3i times 4 equals 12i, and 3i minus 5i equals -15i squared. I squared is equal to -1, so I would rewrite this as 12i minus 15 times -1, which becomes 12i plus 15. And then we would rewrite the expression to match the a plus bi format, 15 plus 12i. Suppose you have two complex numbers, a plus bi and a minus bi. These numbers are conjugates. The product of two conjugates, in other words, multiplying two conjugates together, will always result in a real number. Let's look at an example of when we might need to use conjugates. Suppose I ask you to divide 7 plus I by 3 minus 2i. Well, our goal is always to rewrite our complex numbers in the a plus bi format. We don't want to have a complex number in the denominator of a fraction. So what we can do is we can multiply the numerator and denominator of this expression by the conjugate of the denominator. So we'll multiply both by 3 plus 2i. And then we can distribute using the FOIL method. 7 times 3 equals 21. 7 times 2i equals 14i. I times 3 equals 3i. And I times 2i equals 2i squared which is 2 times negative 1, or negative 2, divided by 3 times 3 equals 9, 3 times 2i equals 6i, negative 2i times 3 equals negative 6i, and negative 2i times 2i equals negative 4i squared, which is the same as saying negative 4 times negative 1, which is positive 4. Notice the two middle terms in the denominator, 6i and negative 6i, cancel out. That's what multiplying by the conjugate will do. Let's simplify the top. 21 minus 2 equals 19. And then we have 14i plus 3i, that equals 17i, all over 13. All that's left for me to do is to rewrite this expression in the a plus bi format. So I'll write it as 19 divided by 13 plus 17 divided by 13i. So there's just a few basics involving imaginary and complex numbers. That's it for this video, and I hope you found it helpful.